All right, it's time for us to get started. All of the announcements. This is the class I really have to have a memory for, all of the announcements. So lots happening this week. Sprint 1 has officially started. We're in lab tomorrow. I expect that the entirety of that lab will be work time for all of you. I will be going around to each group and talking about your design, just have you throwing your design up on a whiteboard or showing me some kind of design document that you've created, something that lets me look at your workflow, look at your process, and I will try to give you some feedback on ways to make that efficient or any potential issues that I see from the design phase to try to hopefully save you some time and some pain as you're working through the Sprint 1 requirements. So that's lab tomorrow. There will also be a small portion of that lab that will be a bit of quiz review in preparation for the quiz that we'll take in here on Thursday at this time. That's a lot just this week. Then we have the client meeting next Wednesday. Tony will be here for that. I will again ask for an order of groups, and we'll all be presenting to the client in that order. I will talk a little bit about my expectations for that, but I'm looking for professional behavior. And because there are 7 teams in this class, that means that you'll have about 1/7 of the total lab period to do it. So there is a lot that needs to happen in that 1/7 of the lab period. You need to show the client, you need to introduce yourselves, you need to show the client what you are working on, get feedback on that efficiently. So think about the workflow of that presentation in advance. Who is responsible for what portions, as well as what do you want the client to test. Be ready to go with a working version so that you can just plug and play and get that feedback. You need to save time in that to also get the requirements for the next sprint. So the client is going to be ready to talk to about what he wants out of the next sprint. You need to spend the time to gather the data to know what you're doing. So both getting feedback and getting the next sprint requirements in 1/7 of 80 minutes is a push. So that will be a challenge. And then the sprint will be due a week from Sunday night. That is plan. Any questions or concerns about that? Anything else about the upcoming schedule? I guess that also next week on Tuesday is your first peer review, so be looking for that to be up as well. And by Tuesday, just submit. There'll be ratings from 1 to 10 for both yourself and every other member of your team on 2 different metrics, effort and technical contribution. So if they seem like they are doing their best, but their best isn't really accomplishing much, then high effort, lower technical contribution should average out to be something that is reasonably passing, again, as long as you're providing effort. The only way that you're going to fail a peer review is low effort, low technical contribution. That's kind of by design for how that works out. But at the end of the sprint, do note that the score that your group gets will be scaled by your peer review average, as long as your peer review average deviates either from the score of the project as a whole or the score of the rest of your group mates. So I'm looking at 2 averages as I decide whether to scale your grade down from that. So if the entire project was doomed to fail and everyone scored low on those peer reviews, I'm not going to double punish you. The poor product is punishment enough. I'm only looking for unfairness within the group. Also, if your score was low, but everyone's score was low because there's just that one group member who rates everyone as a 1 for no reason, and they just hate everyone, then your score won't deviate from the average in the group. And for that reason, I also won't scale you down. So you have to differentiate yourself from the rest of the group in a poor way, in a way that is different from the overall product that was submitted in order to have this count against your grade. And it's mostly useful for me and for you to be able to communicate about the health and fairness of what's going on in the group. So this should not be scary. That is as long as you are giving your best effort, this should not be scary. It should be, is there a difference between how you see your contributions and how your group sees your contributions? That is something that should open up some dialogue about how to improve how you interface with your group. That is the goal of the whole peer review process. Any other questions? I say other, there haven't been any yet. Very quiet group. You go with dead. Looks like Friday in here. That's because it's Tuesday. It's my least favorite day of the week. Yeah. We can talk later as well if there's questions or concerns. Anything else? All right, today we want to cover some code reviews because this is going to be a very important part of your project starting as soon as we finish this. So I was actually, unfortunately, unable to set up something that I have historically been able to do without paying. Now it is a paid feature of GitHub, which is force code reviews into the process. So it is just something that I will also be looking for in the project as a whole is, are people committing directly or are people going through a code review process before merging code into a feature branch so every commit should have a relevant code review before it becomes part of the project. So we'll talk about it. Quality assurance in general is just a very difficult problem in software. How do we know that what we are producing, especially when it's not just you're part of a larger whole, is producing something of adequate quality? What do we want to assure? There are lots of things that we would want to use assurance for. Are we building the right system? That is usually some kind of client interaction. Are we building the system right? That is part of a design question. Do we have the presence or absence of good or bad properties? We need to define what all of those are, as well as what good and bad means with regards to the overall project. What process are we using for identifying errors? When can we be confident that there aren't major bugs in a software release? How do we do that? Is your code robust? That means, is it usable for every possible use case that you're designing it for? Is it safe and secure? Are you leaking data somehow, or have you opened your clients up to some kind of attack from outside? Is it available and reliable? What happens if the server goes down? Do we have backup workflows in place? Do you have automated detection of your systems failing so that someone is notified if manual intervention is required? All of those are part of a quality assurance process. Why would we want to assure our software? Obviously, for business reasons, we want to make sure that the client is happy with what we do and that the software that we produce is as profitable as possible and as quality as possible. We want to deliver what is a professional product. Yeah.
Service tools now and workflow. In computer networks, you use like geolocation API,
yeah,
a government API is down now.
Yeah.
And they're not going to allow that.
That's a fun thing to find, huh?
Yeah.
Yeah. Assuring software is important, especially if it's software that is likely to be targeted. And anytime you are working for the government is very frequently targeted. So it's especially important that you go through a significant assurance process to minimize the amount of downtime and vulnerabilities that could be found. Absolutely. So legal reasons, you do not want yourself to be at legal risk or your client to be at legal risk for something that is your code's fault. Yeah, there are so many examples of that, but legal reasons are a significant reason behind the assurance. People are very trigger happy with regards to suing and trying to maximize the money they get for anything that goes wrong. And any business is going to have that contract protected. Any client is going to be able to look at, all right, if my company is attacked and something happens because of software that you produced, I'll be able to go back to the contract that we agreed on for what was expected in this software. And it's likely that that lawsuit becomes your problem as the development company, unless you would find a way to offload that. Say, I've delivered this to you, I am no longer legally responsible for anything. People don't usually sign off on that. Ethical reasons as well. Just in general, you don't want to design software that has problems that can hurt other people. In many ways of defining hurting other people. For social reasons, personal satisfaction, you want to, the code that you write is your responsibility. If you design good code, quality code, you can be proud of that. And then, of course, how do we assure it? As you start to scale the size of the projects that you are working on, from individual projects to business solutions scale projects, we want to be able to ensure additional qualities of code, like how maintainable is it? When the requirements change or when new technology is available, how easy is it for you to go implement that into your existing code base? If you've written absolute spaghetti, then it is going to maximize the amount of future work you have to do to rework it into the new specifications or to update it. If you hire someone new with a new specialty, how easy is it for them to work with your code? Is your code repetitive in unnecessary ways? The don't repeat yourself kinds of code give two different solutions to the same problem. If so, you better have good reason for there to be two different solutions. Otherwise, it's very confusing. Is your code readable in the first place? If there's an issue with the code, how long does it take to figure that out just by how dense the code is, how well documented it is, how easy it is to determine what is going on? We'll actually see an example of that later today, hopefully. But defect detection rates for various kinds of testing. Unit testing, which is just writing tests for each module of the code, is only going to catch about 25% of defects. And you should expect as much. I mean, 25% is better than zero, so it's worth going through and doing, but there are a lot of defects that are going to slip through the cracks of unit testing. So it is not good enough by itself. If you do functional testing, you'll catch maybe 35%. And of course, that's now using combinations, unit and functional testing. Unit, functional, and integration testing combined, you can get closer to 45%. But that's it. That kind of becomes the cap of if you're just writing the tests and doing nothing else, there are still tons of defects getting through professional code. And it says nothing about the quality of coders in general. You may think, I can do better than that. I've done better than that on the labs that I have turned in so far. But as code scales, it will scale in complexity. The interrelatedness of every component of that gets more and more and more complicated to the point where I don't care how good you are, there will be defects. So finding and fixing as many of those as you possibly can. What techniques can we use to improve what is a fallible process to begin with, regardless of how good you are at it? And the main one we're going to talk about is the code review, because this can catch a significant number of defects, but it's not automated. So a code review in general is just a detailed review of someone else's code, putting someone else's brain to the task that you just think that you solved. In order to integrate the code that you just wrote with the eventual product, we want to make sure that it passes the gut check of someone else who wasn't you. Regardless of how good you think you are, combine it with someone else who's as good as they think they are, that's going to be an improvement. If you can produce 90% infallible code and you pass it to someone else who has an independent 90% infallible code, put your brains together, you'll have solved closer to 99% of the problems. Of course, no one's quite that good, but The idea is that you will be mutually benefited significantly and have a significant reduction in defects by looking at each other's code. So think about the effectiveness of things like spell check or grammar check. That's kind of like writing unit tests, making sure that the syntax is there, that the exact input output is right. Having you editing your own article, it's still your brain. If you don't know a grammatical rule, looking over it 2 or 3 or 4 times isn't going to fix that issue. It's something that's ingrained in how you think about the language that you're writing in. If you have someone else edit your article, now they're applying their knowledge to your writing. So we can edit for things like clarity. Even if you think it's perfectly clear, someone else doesn't think that it's clear, then it stands that it could be improved by talking to that person. It's the exact same thing with code. Readability of code is very important in a documented large-scale project that you have to come back to. So in general, who's involved? The original developer and the reviewer. If you pair programmed this, then it can kind of be a 2-to-1. But if you pair programmed it, don't have the pair programmer be the reviewer. Have someone else review it who has not touched that code yet. You can do this in person. It's often nicer in person to just get a sense of, here is the code. Can you take a look at it? Let's actually have a real-time discussion about it. That's great if you have the time for that. But if you've produced something and it's close to the deadline and you want to get it in there as soon as possible, other people are busy working on their own things, you can just post, I have a code review up. Can someone please look at this code? And someone can do that and give feedback and either accept it or return it with some corrections. This isn't clear. I don't think this does what you think it does. This doesn't match the documentation at the top. Something like that to go rework something before it becomes part of your product. What happens? Improvements at the logical or structural level. This is why we have those code standards as part of a channel in your Discord so that you can all agree on what standards you are looking for with regards to this. So if someone submits code that doesn't adhere to those code guidelines, then you can return for that reason. If you give good feedback, the code that is eventually part of your project will be significantly higher quality, which means that when you have to go refactor it, it's easier. When you have to go make changes to it, it's easier. When you need to go extend it, it's easier. Once that process has been done, make sure that it goes through another code review. So just because you fixed the issues with the first code review does not mean that it's automatically going to be accepted. It should still have someone look over it. And the best code review is done if it goes into a second review, have it go through a 2-part process. One by the original person who did the review to say, did this meet the issues that I identified? And you can even go through a second person that says, does this meet the issues brought up by the first person to your standards? Eventually, your code gets approved by someone who wasn't you, and that way you all have a bit of awareness over the parts of the project as they become part of your project. That leads back into the bus factor as well, and we'll talk about that in a little bit, but I can summarize it now of just saying that if you code review someone else's code and then they're incapacitated for some reason, then you know what they wrote and you've looked at it at more than a glance of a level. You looked at it to the extent to which you know what it did when it was part of that product or project, that commit as it was put into your project. And it works a good bit better. When do you want to do a code review? Any coherent system change. So you don't want to code review a single line of code, but you also don't want to wait until an entire class with its many components has been completed necessarily. By the time someone is ready to commit a reasonable size change to your repository, a code review should be about 1 page of code at most, in my opinion. If you're trying to ask someone to look at more than that, it's going to overwhelm them. There are going to be interdependencies within that much code that are harder to recognize, analyze, and constructively criticize than a chunk of code that is digestible, that does a small thing, a small piece of a larger whole. But you want to make sure that it's done before committing the code to the repo. And especially before it's been incorporated into a release build. Everyone should be on board with the quality of their product before you release it to the client. Why do it? We know that one person has seen every piece of code, but now we know another person has seen every piece of code as well. So raises the quality threshold, improves the bust factor. Knowing that your code is going to be reviewed is going to help you to be able to produce better code from the first place. You know that it has to pass a code inspection by someone who isn't you. You'll be thinking about it in your development process. Question on chat, should we commit it to a feature to be reviewed before committing it to the dev branch? I would say even before putting it in a feature branch. So before even being part of your project in general, unless the feature is so small that it would have fit into a single commit in the first place. So if the feature is so standalone and like the feature would fit on a single printed page, then you can code review that feature branch, merge it into dev kind of as a whole triangle. But I like to think of it as once we're ready to commit a workable piece of a feature, that should be code reviewed. Great question. So yes, hands-on learning experience for people also is great. In general, your team members are involved with different parts of the system. Even if you break apart the system in ways that you're working on something, someone else is working on something else, there's going to be overlap by the fact that you're forced to do peer reviews across those boundaries. So you'll start to get a sense of how your program fits together, even if you're just off designing a small piece in your own independent part of the project. So it's just another form of communication and all being on the same page. Both the author and the reviewer are accountable for committing code. That means that if you reviewed code, it is the quality of that code is also your responsibility, even if you didn't write it. So if you're thinking about pointing fingers and blaming quality of this didn't work the way that it was supposed to, and you were the person who reviewed that code, point that finger internally as well. There was something there that you should have paid more attention to at the code review process. And we don't do any of this to point fingers at each other. It's to ensure the quality of the code. So none of this should be personal or feel personal. It's all part of a learning experience and part of improving the quality of the project. If we have design inspections and code inspections paired with everything else, we can get the defect detection rate all the way potentially up to about 60%. That just shows how bad people are at logic. And seeing the entire scope of the size of what we produce in industry compared to how we have to interface with it. It is so complex that even the best of us don't have a hope of catching everything, which is why we need bug testing. We need user reports. We need something that feeds us information that helps us to identify what are those defects so that we can go hunt them down and fix them. To give you a case study, an example of how this works in practice, there were 11 programs developed by the same people, so they accounted for the quality of the coders themselves. First 5 were done without code reviews at all. And per 100 lines of code, there were 4.5 errors on average. And these are industry quality developers. Next 6 were done with reviews, average of under an error per 100 lines of code. So reduced by over 80%. So this process does work. It's not infallible at all, but it works, and it works very well. So if you find yourself naturally thinking about shying away from it, try it out. Give it a shot for this quarter, and you will see the results. I would almost say that instead of being a very common industry process, code reviews are mandatory. If you find yourself working for a company that does not have mandatory code reviews, run away very quickly. There are plenty of advanced tools that help with code reviews. So just about any company with any level of profit, one of the first things they're going to invest in is the ability to make the code reviews higher quality, make them easier on the developers, take less time, automate the workflow, allow you to highlight changes that are made. That's built into Git as well. Allow traversing back in history of some kind. There are also variations on the code review. So we should talk about the different levels of code review that we can go into. So an inspection is an even more formalized code review, where there are associated roles within that. So there's a moderator, there's the person who wrote the code, there's a reviewer, and there's the person taking notes about what the reviewer says to incorporate into that. So you may have multiple reviewers, and this is for especially critical portions of code that need to function and cannot have any defects in them whatsoever. You have a very specific checklist for the kinds of flaws to look out for, to make sure that every single reviewer is looking out for every single potential issue with this code. Part of that could be focused on flaws that were identified before in a past code inspection. Could focus on very high-risk areas, security, dosage monitoring, something that might be very critical to the health of a human, the safety of a human, the security of a human's data. There are also expected outcomes from an inspection, some kind of actual report that is generated, a list of defects, possibly even a way of handling, a plan of action for each of those defects, who's responsible, what does a fix look like, what is the timeline for that fix. On the other side, we can move more informal rather than more formal, and you get a code walkthrough, which is just a discussion. Two people sit down, and rather than one person trying to identify flaws, it's just communication. Here's what I did. Here it is working. Here's an example of it running. Here's what inputs to put into it, and here are the outputs that it generates. See, I did great. So an author and a single reviewer, this is more communication than it is trying to identify flaws. If there are large-scale flaws, then the person looking at the walkthrough will be able to identify that, but it's mostly a communication tool so that everyone is on the same page with how to utilize the components of the project. There can also be a code reading. Reviewers by themselves looking at code asynchronously, usually for just understanding. This is to get a sense of how readable is the code. Do I see any issues by themselves without having immediate access to the person who wrote this who can answer those? So something that is more offline. Everyone is busy. The person who wrote the code is busy. You can still make that work. In general, how code reviews work at Google. All code that's submitted needs to be reviewed by at least one other person. Either the code writer or reviewer needs to have readability in that language. That's the industry term, just in terms of can you quickly and easily understand code written in a particular language. And you'll go through exams to get readability in a particular language. That gives you that role, the ability to review in a particular language. So here's an example of some software for code reviews. A large amount of time is spent reviewing code. At Yelp, use a review board. Engineer works on a branch, commits the code to their own branch. Reviewer goes through the diff, just determining what is the difference between the old code and the reviewed code. adding inline comments on the review board and then sending them back. So what you get back as a developer is a lot of comments on the code from a review board. Multiple people who have looked at that code and annotated it for the concerns that they have. Meant to be a dialogue. So comment threads can result from that. Not just, here's feedback, go fix, but you can comment on the feedback to get more specific feedback. You can start to brainstorm potential solutions with the reviewers who identified the issue in the first place. Maybe they're an expert in a potential solution to this, which is why they identified it in the first place. So there should be that kind of dialogue. Wizards of the Coast uses Perforce. Work with stuff that manages rules and content. So we try to commit changes at the granularity of one bug at a time or one card at a time. Team is small enough that you can designate one other person on the team as a code reviewer. You will see this very frequently. If you work for a larger scale company, the review process will be more involved and involve more people. You work for a smaller company, it's a smaller process. Usually you look at code sometime that week, depends on priority. It's impossible to write sufficient test harnesses for the bulk of our game code, so code reviews are absolutely critical. And we'll see this when we start talking about testing as well, the trade-off between how much time and effort is spent on creating these kinds of test harnesses versus the amount of time that you spend doing code reviews. Given the size of your team, the crunch that you're on, there's going to be a different workflow that makes sense to maximize the quality of your code, given how much time you can reasonably spend on it. The more time you have, the more time that you should not spend doing in-depth code reviews, but spend actually writing the test harnesses and then do a faster pass at the code review, knowing that it already passes the test harness. Another one at Facebook, have an internally developed web-based tool to aid the code review process. Once an engineer is prepared a change, she submits it to this tool, which will notify the person or people she has asked to review the change, along with others that may be interested in the change, such as people who have worked on a function that got changed. At this point, the reviewers can make comments, ask questions, request changes, or accept the changes. If changes are requested, the submitter must submit a new version of the change to be reviewed. All versions submitted are retained, so reviewers can compare the change to the original or just changes from the last version they reviewed. Once change has been submitted, the engineer can merge her change into the main source tree for deployment to the site during the next weekly push or earlier if the change warrants quicker release. So even across large scale industry companies, there's a different approach to this whole process. But they're all thorough processes that depend on a few factors. A lot of that is just the size of the company and the amount of time that they have. Code reviews for this class, you need to document the review in some fashion. So if you're emailing back and forth, Discord messaging back and forth, some way you should have some kind of log of the reviewing that you do. And that way I can check and make sure that code reviews are actually happening. I can also tell from the GitHub history when there is a code review on something. You can always request, and this should be the default behavior, request a review before you commit the code. So do not just hard commit code, hard push code onto your remote repo. Make sure that you open a code review of some kind. Common arguments against them that I've heard historically. I really don't like doing a code review every commit. It takes too long and wastes time. I want to make lots of commits, and asking everyone all the time to review my commits slows me down. In general, how would you respond to hearing something like that? Any ideas of what an issue with that mindset might be? How would you help react to that mindset?
If you don't do it right the first time, we're just going to do it again.
Yeah. That wastes your time as a reviewer. You're going to review it and review it and review it and review it. And if you just want to commit those changes and they become issues in the repository, that's significant debugging work that's going to happen after I can isolate it down to the code that's in your commit right now. Everything we can identify right now is easy to find and fix. It's embedded in a small, easily digestible chunk.
Yeah, I was gonna say that, I'll just tell the person like, if you make a bug in one of your earlier commits, that's gonna propagate throughout your entire, all your code.
Yeah.
You know, catch that before it even starts becoming a
Yeah.
problem.
Absolutely. Also, maybe you're making too many commits. If you're trying to save your work in the repository after you change a single line of code, or after you make a 3-line method, then maybe you should be decomposing this more into the functionality and waiting until you have a full functional small feature complete. Test that yourself within your project, and then you're ready to get a code review for it. So when you go to ask for a code review, it should be worth the reviewer's time to verify. They should not be finding small things that you could have found yourself easily. That's still going to happen, but try to minimize how frequently that happens.
So when we code review, we should expect there to be like unit tests already in the code, right?
Eventually, we're gonna have tests on GitHub themselves, so we start talking about tests, starting with the next sprint, there's gonna be, from my perspective, requirements for how much code coverage you have, what tests are written for what portions of your code. So writing those unit tests as you write the code to incorporate both the functionality and the tests into the test harness that you're building for the entire application will become part of the workflow. But for this first sprint, the requirement's not there. If you have a history of writing good tests, start now. It'll make your life a little bit easier later on. Yeah, great point.
You look up previous commits, like for example, I noticed 5 days ago under my name, I created the 2 accounts on their main and
Mhm.
dev. It was called, what are they called? AI folder and AI file. I've never remembered doing that. And it was
Yeah,
on the
I saw
book.
that on Discord. I saw that discussion on
Yeah,
Discord.
and I was like, man, what's going on? And I was trying to delete it, but I deleted it, but then somebody thought that maybe we're supposed to have it because maybe you guys did it, the teachers at TA
Yeah.
or whatever. So, what my question is, if things like that happen, is it okay to revert back to normal?
Yes,
Are you gonna be
please
like,
do fix things that if you notice there's an issue that has been created, revert it.
okay, you're not gonna look at it like, well, these guys are committing and reverting too much crap, I'm gonna give them half the
I'm
points.
gonna look at the health of the project as a whole and the workflow of the project. I expect mistakes to be made. That's just the nature of being new at this.
Uh-huh.
The question is, do you do something intelligent about that mistake? What does the workflow of that look like? If you are if one person is always committing directly to main, and then another person is constantly fixing that, then there's gonna be I can identify a communication issue between you.
Okay, I see.
That there's something that the person who's fixing it should stop fixing it and fix the workflow issue with the communication issue with the person. So that I can see using against the group, because that's something that you should be finding. But yeah, no, if you're actively fixing and keeping Git flow throughout the process, then you will not receive points off for that. But if you are continuously merging things into places they shouldn't go, committing places they shouldn't go, that will also get a deduction, just because.
I just don't know how it even happened, like,
And
I never had any of those folders on my
Yeah.
computer.
every grade is always, it's never set in stone. If there are reasonable arguments, like here's what happened, here's the background, here's context, I'll take all of that into consideration. There will be some grade that's out there, but if you disagree with it to a significant extent, talk to me about it. I can't guarantee I make changes based off of an argument, but I want to take your perspective and what happened, what actually happened into account to make sure that the grade that you're assigned is fair from my perspective, that I'm not missing information when I assign that grade.
Gotcha,
I want to be fair to you.
I gotcha. You saw that conversation last night?
Yeah.
You read our Discords.
Let's take passes, especially early in the class. I assert if I feel like there's something that I need to assert about, but it seemed like by the time I looked at it, it was like, all right, we fixed it for the most part.
Yeah, delete it, leave it like that,
Yeah.
it's done.
That's fine. So too many commits. You want coherent, complete changes to be part of a commit, not just every single line that you write. So please don't commit so frequently that you force someone to code review every line that you write separately. something, if you can't test it yourself by yourself, you shouldn't be committing yet. If it was quick to write or a small change, it should be very quick to code review. If you write a 4-line method, and that is a whole feature and function that people should be able to use, don't wait for more. Commit it, but it's also only 4 lines. Tell someone I have a really quick code review for someone, here's what it does. And that process should be very fast. If, yeah, the point we already made, if you check in buggy code, it'll take way longer to find once it's integrated with the rest of the project and is doing as communication responsibilities with every other aspect, that you're gonna have a significant debugging project ahead of you to figure out where the issue is. Tried doing code reviews, but it was not useful. We never find any bugs or errors. The code is always approved. This can either be because the reviewer is not thorough enough. If people are just using it as a check mark and not applying the actual review process to the code, then it is a complete waste of time. You're right. Any review of non-trivial code should uncover some issue. So if you're a code reviewer, keep that in mind. If you're not seeing anything, there are no issues with anything that is ever being, that you're seeing in code, it's probably because you're not diving into the logic deep enough to identify those issues. Sometimes the point is not just to find flaws and fix them, but to be aware of what the other person is working on, other functionality in your code. So even if you don't find any issues, the code review can still be worth time for that reason. And if the original coder knew it was going to be reviewed in the first place, there are probably fewer issues that were there because they knew someone was going to be looking over. All right. Changes to this code. Someone commits this code for some garbage accounting software, and your task is to come up with what you would comment. How would you review this code? What feedback would you give this developer?
Already, like, couldn't public static final 8, couldn't that just be an enum?
Yeah. It could be. That is one of the things I have identified.
I would say it needs to be commented on more. The comments
Yeah.
are definitely like, they seem more like personal comments and not like.
How much work do you have to do to read this code? You all have readability in Java at this point. If you can't immediately read this and figure out what's going on, there aren't enough comments. There are not high-level comments that describe what these functions are doing, or why this account has the fields that it does.
Also instantiating all those different things on the same line, like, I feel like they need to be more related if you're gonna be instantiating the same line. Like, that's not readable, because I'd be like, okay, there's a common there, and then there's a.
It's like a giant one-liner, dude.
Yeah,
Yeah.
it's like,
Oh.
you can't read crap.
There are also tons of what we call either magic values, magic constants, something that should be factored out as a constant embedded in the code itself, even if you don't use it more than once. But these values like 365.25, what does it represent?
The amount of days in a year.
So you could have some kind of static days in year equals, just factor that out. And now we have a variable name for this constant that just appears in our code. And then you would increase the readability by, in the middle of the code, you would say days in year. And that is significantly more readable than just having a number that now you have to think about, what is it, why is it there?
Whoever wrote this is a beautiful feature in malware.
I will find this person.
There are still a couple, there's one really big issue we haven't identified yet, yeah.
The comments are a little.
Yeah, yeah, that's kind of an okay style for a personal project, but for professionally documented code, it's more like a reminder to the coder of what this does. If you find yourself wanting to put something in there, then that's something that should be embedded in the code itself, like interest principal. This means that there's an expression representing that, and it should be spread over 2 lines. Interest principal equals some sub-expression, and then in the combined expression, use interest principal. Now you've completely eliminated the need for that comment.
Is that whole if statement not in curly brackets?
It actually is a single line, so it doesn't need to be.
Oh,
So there's significant readability in that concern of how many lines is that? Is it an issue because only the first line of multiple lines is embedded in this if statement? You have to go through and verify for yourself that this is a single statement, and so it's okay for those to be omitted. That's not readable. The fact that you can't immediately see that is a problem. There's a big security vulnerability in here. We see that. Maybe there's one other issue.
I was gonna say, just for aesthetics purposes, use a formation.
Yeah. We don't have consistent white space. That's another thing. We don't have consistent line breaks in this. We kind of mentioned that with regards to readability, but what's the security vulnerability?
The way that they're trying to determine account type, it would be really easy for the user to go in and change that final because it's a publicly inherited file.
Yeah, the fields are all public. That's bad. If that is the last thing you noticed about this code, that's also pretty bad. In general, fields of all objects should be private unless there is a very good reason for them to be public.
So, doesn't look like that's a closing typo.
Yeah, so lots of issues, even though this code would function perfectly and pass whatever tests were set up for its functional intention. There are still lots of feedback that you can give on what looks from a testing perspective like viable code. So let's go from this to a fixed version of this. Night and day difference in the readability. This is exactly the same code. One of them was written by someone who I would put back in CS1. One of them was written by someone who I could see putting forth part of a project in this class where I go, yes, I want to join that team. This is beautiful to review. And if this looks like something that you generate, awesome. If this does not look like something that you generate and you write code that looks more like this, there is a lot for you to learn, I think, in the code review process for being able to generate something that is readable. Because as soon as you have to interface with this code, you're almost excited. It's like, what can I add to this? How can I work with this? You see the other, it's like, is there another team in here I can join? So that's part one, that's part two. In general, it's just significantly more readable. We'll end with just a general checklist of if you were to generate some kind of checklist for this class, what should you be thinking about and looking at in a code review for this class? Think about sections like coding style standards. To what extent does the code that you're reviewing adhere to those standards that you agreed upon? About the comments. Where are the comments? How verbose are the comments? Are they overly verbose, not verbose enough? Do you get a sense from reading the comment of what the program does? Do you feel like the author should tell less of their life story in their comments? Or do we need to have a better understanding of what the code is doing from the comment because you have to look back at the code to figure out, in general, what is this doing? That should be something that you read from the comment itself.
My coding is my therapy. Okay, it's cheap.
Everything's cheaper than therapy. Logic in general, not to turn people away from therapy, but it's very expensive for what it is. Very expensive, very worthwhile, very expensive.
There's rage rooms.
It depends on the type of therapy. So logic, how correct is everything? Error handling, what happens in those edge cases? What happens when something that we don't expect happens? How thorough, how nicely does our code break? Does the user get to save their work? Or something like a UML editor, if the user tries to do something that breaks the code, do they have an opportunity to save before it breaks? Is there some way to recover from that? Or did you just say, screw recovering, I'm just gonna crash? So there's a lot from even just a usability perspective of that again, has nothing to do with the actual functionality, the intended functionality of the program, but when something goes wrong, do you handle that from? In general coding decisions. So if you're using a particular data structure, why? Is it the right data structure to use? If you're using a particular algorithm, is it efficient? Is there a better option here? So commenting directly on the code in the commit via code review, just fine. I can see that history. Please interface with it. Just set up that code review and make sure that you're going through. It's called a pull request. So you're going to set up a pull request in order to set up this code review. Questions on this? Yeah.
And you guys are gonna do some your training, are you guys gonna look for the closed pull requests or for the history for that?
Yep. Yeah, just to get a sense of where there are significant commits without pull requests. So yes, I am looking for everything to be pull requested, code reviewed, accepted. That doesn't allow for me to see the quality of the code review that was done, but that'll be inherent in the quality of the project.
Or should, if you're doing the code reviews through the comment system.
Yes, I can see the comments that are there. I can't see the comments that aren't there because you didn't catch it, unless I'm going through and doing every single code review for every single. Yeah, so I can see at a bird's eye view the quality there, but. For once, I almost hit the exact time frame that I wanted. But